Okay, in this video I want to talk about the slope of a line. And the slope of a line is a measure of the steepness of the line. So steeper lines will have a bigger slope. And before we can talk about the slope of a line, we should talk about the slope of a line segment. So slope of a line segment. So here are your axes, x-axis and the y-axis. Let's say that you have a line segment. So let's say you have a line segment that's here and that ends here. And that's our line segment. Let's label this first point A, and let's label the other point B. And let's say that the coordinates of A, now I'm drawing just random points, okay? So it's not necessarily, in the picture I drew A to be 1, 1 and B to be something else, but in general, let's just call the coordinates of A x1, y1, and the coordinates of B x2, y2. Okay. Then the slope, now I'm going to introduce this term, the slope of the line segment AB is defined to be y2 minus y1 over divided by x2 minus x1. Okay, let's explain what each of these things are. So if you have this, pretend that you're going from A to B, okay? This length is how much x changed in going from A to B. So A was x1, right? The x coordinate of A was x1. The x coordinate of B is x2. And so if you start with x1 and add x2 minus x1, you end up at x2. And similarly for B, for the y coordinates, when you start from y1, okay, to go to y2, you have to add y2 and then subtract y1. So y2 minus y1 is the change in the y coordinate, and x2 minus x1 is the change in the x coordinate. And what you're doing is you're dividing the change in the y coordinate by the change in the x coordinate. So this is the change in the y coordinate divided by the change in the x coordinate. So here's an example. What's the slope of the line segment between 0, 1 and 3, negative 2? Well, pick one of them to be x1, y1, and the other one to be x2, y2. Let's pick this one, 0, 1, to be x1, comma, y1, and 3, negative 2 to be x2, comma, y2. So the slope is, well, it's defined to be y2 minus y1 divided by x2 minus x1. That is going to be negative 2 minus 1 divided by 3 minus 0. On the numerator, negative 2 minus 1 is negative 3. 3 minus 0 is 3. And negative 3 divided by 3 is negative 1. Let's draw a picture. So 0, 1 is here, okay? And 3, negative 2 is here. So I'm looking at this line segment, and the slope of this line segment is -1. So some facts about slope that are important. First of all, the slope of a line segment does not depend on the order that the points are named in. Let's just do an example with this one, and then you'll see what's going on. So let's say that, so the way I did it is I called 0, 1, x1, y1, and then 3, -2 was my x2, y2. Now let's say that I decided to call 3, -2, x1, y1, and I decided to call 0, 1, x2, y2. Okay, what would I get when I do the slope formula again? So y2 minus y1 over x2 minus x1. This time I'm using the other, right? This time my y2 is 1, and my y1 is -2, and then my x2 is 0, and my x1 is 3. Well, when I get that, I get, on the top I get 3, and on the bottom I get -3. 3 divided by -3 is -1. So notice that I get the same number, -1, either time. And if you think about what's going on, why did you get the same thing? If you look at these two calculations, okay, look at the numerators and look at the denominators. Actually, it's probably easier to even just look at the numerators and denominators here. Right? For the first numerator, I had -3. For the second numerator, I had 3. For the denominator, the first one was 3, the second one was -3. They just were multiplied by -1. And so they ended up canceling, and the quotient ended up not changing. And that kind of makes sense if you think about why would the numerator and denominator be multiplied by -1. It's because you switched the y1 and y2. Like if you had y2 minus y1, that's -1 times parentheses y1 minus y2. Okay, so it doesn't matter which, when you're trying to find the slope of a line segment between 2 points, it doesn't matter which one you call x1, y1, and which one is x2, y2. On the other hand, if you called one of them, x1, x2, and the other one y1, y2, then you'd be in trouble. Because then you'd get something else, and that doesn't have any meaning in terms of the line segment. Okay, you're going to get a number, it's just a meaningless, it doesn't mean anything about the line. In this case, the steepness, the slope is -1, meaning that, okay, the steepness is -1. And we'll see you might see already that the fact that you have a negative slope means that the line is going down. Okay, from left to right. Okay, so that's the reason for number 1. And then number 2, that's the first fact. The slope of a horizontal line segment is 0. Now why is that? So let's say I have a horizontal line segment like this. And let's say this one's A and that one's B. Now usually A will be the one on the left, my x1, y1, and then B will be the one on the right. As we just saw, it doesn't matter which one you pick, so you might as well just make x1, y1 the one on the left. Okay. Well, what's going on here? A is your x1, y1, B is your x2, y2. Since this line segment is horizontal, right, it's not going up or down, what does that tell you about y1 and y2? They're the same, right? They're the same y coordinate. So this tells me that y2 is equal to y1. So what do you get when you do the slope? You get y2 minus y1 all over x2 minus x1. Well, what's y2 minus y1 equal to? y2 is equal to y1. Subtract y1 above. I mean, they're the same, so when you subtract, you just get 0. So 0 over x2 minus x1, and of course that's 0. So the slope of a horizontal line segment is 0. Which kind of makes sense. If you think about it intuitively, it's not steep at all, right? So it's a good thing that the slope is 0 when you have a horizontal line segment. Now 3, the slope of a vertical line segment is undefined. So if you have a vertical line, it has an undefined slope. Well, what happens if you call, say, this point x1, y1, and that point x2, y2? Well, in this case, since it's vertical, what does that tell you about x2 and x1? They're the same, right? Vertical tells you that x2 is equal to x1. So you can see right away from the formula for the slope, which is really the definition of the slope, the way we're defining it, this would be undefined, since x2 is equal to x1, and so x2 minus x1 is 0. So this denominator would be 0, and division by 0 is undefined. Okay? Yeah. And one way I think about what's going on with vertical line segments, why that is not a bad thing for a vertical line, to have a vertical line segment to have an undefined slope, is because if you think about like a horizontal line like this, and then it getting steeper and steeper and steeper, it's like an infinite steepness. So that would be undefined. Okay. That gives you some intuition for why it's a good thing that the slope of a vertical line segment is undefined. And another fact is that the slope of a segment, meaning a line segment, that rises from left to right is positive. So if I have a line segment that's like this, that's rising from left to right, it has a positive slope. Now, why is that true? Well, let's say that the first coordinate, the one on the left, is x1, y1, and the one on the right is x2, y2. So we have x2 minus x1. What can we say about x2 minus x1? Is it positive, negative, or 0? Well, x2 minus x1 is positive because x2 is bigger than x1. And what about y2 minus y1? That's also positive because y2 is greater than y1. So remember, the slope was y2 minus y1 divided by x2 minus x1. Well, you have a positive number, y2 minus y1 is positive. This is a positive, and then divided by a positive number, x2 minus x1 is also positive. Positive divided by positive is positive. Right? So it's greater than 0. So the slope is greater than 0. Similarly, if you have, okay, I'm going to put parentheses here, respectively descends. So in other words, replace the word rises with descends. From left to right, the slope is negative. And let's just draw a picture to illustrate what's going on. So again, we're labeling, we have this line segment that goes that goes down as you go to the right. So if this point here is x1, y1, and the second point is x2, y2, then again, x2 minus x1 is positive because x2 is bigger than x1, but this time, what's different? This time, y2 is less than y1. So y2 minus y1 is negative. So then when you calculate the slope, okay, y2 minus y1 is negative, x2 minus x1 stays positive, negative divided by positive is negative. So that's why the slope of a line segment that goes down as you go to the right is negative. Okay. And then a couple more things that's related to that is when you have, so I'm just going to label my axes, x-axis, y-axis. Let's say I have a line segment that goes up as I go to the right, like this. And let's say, again, the one on the left is x1, y1, the one on the right is x2, y2. Okay. As we just saw, this vertical distance, this vertical length is y2 minus y1. And this horizontal length is x2 minus x1. And I have this right triangle. Now so let's say this point is A and that point is B. So in this case, right, if you have a positive slope, which is what I have in this picture, then the slope is the ratio of the lengths of the legs of the right triangle. So in other words, you take, let's call this point here C. Okay. This would be BC divided by AC. Because the length BC is y2 minus y1, the length AC is x2 minus x1. On the other hand, if you have negative slope like this, then, okay, let's call this point C. Okay, so if this A is x1, y1, B is x2, y2, then C is going to be x2, y1 because it's the same x coordinate as B and the same y coordinate as A. Well, what's the change in y? The change in y is y2 minus y1. But the length, BC, the length of this line segment is negative of that. Right? In this case, y2 minus y1 is negative because y2 is less than y1. But the distance from B to C is just positive. It's positive, and it would be negative 1 times y2 minus y1. So that's that's y1 minus y2. So the slope, okay, well, we know that the slope is y2 minus y1 over x2 minus x1. Now notice that the length of AC is x2 minus x1. So this is going to be negative BC over AC. It's negative 1 times the ratio of the legs of the right triangle. Okay, so that's what I wanted to say about the slope of a line segment. And in the next video, we're going to talk about the slope of a line. Thanks.